Hi, welcome to our math. Today I'm doing a series of videos on scatterplots and lines of best fit. Here it says a teacher was trying to determine the amount of sleep a student got correlated to the score they earned on an exam. Okay, so he had the students document how much sleep they had, correlated it to the score they earned. The first thing it says is create the scatter plot. I have gone through 865, so 670. I figured you didn't really need to watch me plot all of the points, 1088, but it's good to see that, this is 85 and this is 90. I'm going to go close to 90, but this is a scatter plot. It's not about perfection. If it was, you would have to have more lines on the graph. 890, that's a nice grid point, set 675. 780, and then 895. Okay, so now we are all graphed. I do want you to note that there are two data points that are the same. That's pretty common when you're talking about data points. This is a pretty good scattering of points, but usually if there's like 60 points on an exam, there are certain grades that you're going to see over and over. And there's only so much difference in how sleep is being given to you as a number. Then it says, what criteria gives a good eyeball line of best fit? There's lots of ways of doing line of best fit. You can use Excel, you can do a lot. There's several different mathematical practices you can use in trying to find a line of best fit. We're not going to use any of those. We're going to do the eyeball. And that is exactly what it sounds like. It's using a ruler and your pencil and just kind of coming up with what you feel is the best line to represent the data. Now, there are two criteria I tend to think of when I do an eyeball line of best fit. The first is that the line goes in the direction of the data. And I'm starting with direction of the data because I have gotten students very fixated on the splitting of the points, and they'll come in and they'll try to find a way to perfectly split the points, and they are missing the idea that that line with a negative slope will not represent this positive correlation. The second idea is what I just said, is that the line should generally, and I'm going to say generally because sometimes you have outliers, sometimes you have clusters of points, like there could have been, somebody with 2 hours of sleep got 100%. There are lots of different things that kind of sway your line one way or the other, but generally we want to split the points. It's this generally splitting of the points and generally in the direction of the data, which means everybody's line of best fit is going to be a little bit different. It makes writing answer keys for these things really difficult. I usually try to prep my videos. The problem is I never draw the same line of best fit. It's close, but it's never precisely the same. So here, this is about the direction of my data. So I'm going to kind of try to cover about half the points, kind of come in here. And once I get kind of about half the points covered, do I have to? Nope, that's too few. Once I have about half the points covered, I'm just going to come in and draw my line of best fit. Now I want you to notice, I'm not going to put an arrow down here. Probably don't need to up here. Probably can't really get above 100%. This right here is a break in the graph. And what this says is none of the scores are below 60%, so I don't need any of this data. It's kind of like if you accordion fold your paper and say, we are going to start right here. The other way of doing this is changing the label to say scores above 60%, and then you'd have 60, 65, 70, 0, 5, 10, 15, 20, 25, 30, 35, 40, where that's 60 and that's 65, and you just have to realize that if you get a 35, it's not 35%, it's 60 plus 35 or 95%. This is simpler if we don't need any of the data down here. Okay, so now that I have the direction and generally splitting the points, I want to find two data points. Now, not data points, I want to find 2 points on the line. I want you to ignore all the data points. I want you to pretend they're not there. I want you to just really focus only on the line of best fit. One line to rule them all. That is all we are looking at right now when we talk about a line of best fit. So I ignore the points. If I ignore the points, I see that this looks like actually a really good point. 5 hours, 65%. My next one that looks pretty good, if I want to get a easily translated one, this one looks pretty good. That's 8.5 hours of sleep and about an 85%. Okay, notice when I find 2 points, I write them as ordered pairs with parentheses, comma delimited. If you're not using the parentheses, you're not writing an ordered pair. Once we have our ordered pairs, we don't care about the data anymore. We don't even care about the graph. All we care about at this point are those 2 points and writing an equation of a line that represents the data, but we're no longer looking at the data. So we ignore everything but the 2 points. Now it says find a model for the grades based on hours of sleep. Notice you're given the variables to use. Don't miss that. If you're told which variable to use, you should use those variables. Okay, to find a model, that means an equation, and we're doing lines, so a linear equation. Start with slope. M equals 85 minus 65 divided by 8.5 minus 5. So I have 20 over 3.5 and 20 over 3.5 is 5.7. Now, even though 20 over 3.5 could be written as a decimal, we could put this as 40 over 7, or sorry, as a fraction. A fraction is not allowed when you're talking about data because that line is not representing all the points. All the points are never going to fall on the line. This is all guesstimation, generally the direction, generally splitting the points. A fraction implies perfection. A fraction tells a story that everything is precise. A fraction is really a math world thing, not a real world thing. We have to realize that this line is representing messy data that isn't all on the same line, and the way we represent messy numbers is with a rounded, error-filled, messy decimal. So we have to go to decimal. Even if this ended up as 2/3, we would go to decimal. Okay. Now we're given the variables. You could do y and x right now, but we may as well just use the variables given to us. So for my equation of the line, g minus 65 equals 5.7, h minus 5, and then I can nicely distribute the slope in. G minus 65 equals 5.7h minus 28.5. And then we add that 65 over. And after I add the 65, I'm going to change my notation back to function notation. So not just g, but g dependent on h is 5.7h. Always make sure your slope comes back, plus 36.5. Okay. So it's kind of confusing because you're like, wait, but 3 hours of sleep is 0. But remember the accordion. If this got stretched all the way down, that actually makes a lot of sense. Okay, so then it says, what is the slope of the line and what does it mean in the context of the situation? Okay, make sure you never forget notation. Ordered pairs have parentheses. Slope is not just a number, it's a labeled number. M equals 5.7. That is important that you have the M equals when you're writing a slope. Next, it says, what does it mean in the context of the situation? Okay, when you're translating a slope, when you're translating an ordered pair, when you're doing this translation, what does it mean? You have to imagine you're telling somebody. So your teacher does this data. Your teacher isn't going to throw a bunch of data at you without telling you what it means. It doesn't say it's a math teacher asking you to do the math. Maybe it's a gym teacher and they gave a test about something and wanted to know the difference between scores and sleep. Maybe it was a physical test, not a paper test. And there's no paper in the gym room, so the gym teacher just wants to say, hey, you told me what your sleep was on the test. This is how I used it. And they want to give the information. So what does it mean in the context of the situation? Well, slope is based on our ordered pair, and our slope is the change in y over change in x, and y is score, x is hours, knowing your labels, knowing this is your score, this is your hours, this is our ordered pair. Knowing your labels helps your translation. And I know I did the technical y over x versus g over h. Stick with me here, I was going true math world. So this is really 5.7 over 1 if we wanted to make it a fraction, which we really don't, but it is the output, and the output is, I have this backwards, hours scores, sorry. I even have it right here correctly. Okay, hours scores. Output is over here. This is always what we care. At the end of the day, you really care about what you earned on your exam. So the exam score, now when we're translating it, we don't say negative positive. This is a positive slope. That doesn't seem as applicable, but if it was a negative slope, we wouldn't say negative, we would say decreases. But in this case, it increased by about 5.7% per hour slept. What is a vertical intercept and what does it mean in the context of this situation? That's going to be the 0, 36.5. A student who gets 0 hours of sleep will earn about 36.5%. Okay. Using your model, what score will a student earn if they sleep 6.5 hours? Now we could go back to the data and see, 6.5 is a pretty nice 75, but that's, sorry, 6.5 isn't on here. There's no data points, but if it was 6, we would have different data points. But it doesn't say go back to the data. It says specifically use your equation. So notice here, this is an H and this is an H. They're the same. That's what function notation does. It tells you the letter in the parentheses is your input, and that input should be seen on the other side of the equation. So if I'm putting 6.5 in, I'm going to say G of 6.5 because that's what I'm substituting in for hours, and it should appear in both iterations of that H. And this is kind of a big deal. What does it matter? Well, we're using math notation, we're using shorthand, everything has a meaning. If you're not a stickler for the specifics about what you're doing, then the translation is lost. If the translation is lost, then communication breaks down. Since we're not using full sentences, this is how we have to communicate. So we have to make sure our notation is correct. Okay. This is 73.55%. Doesn't say in a complete sentence, so I'm just going to do it as a percent. Using your model, how much sleep should a student get if they want an 85%? So now we want to know if it's 5.7% per hour plus a generic 36.5. What do we need? How many hours do we need to get an 85? So I'm going to subtract the 36.5 from both sides. 5.7H is equal to 85 minus 36.5. which is 48.5. Divide both sides by the 5.7. And we get that they should get about 8.5 hours of sleep. I know you're saying, hey, that was our initial ordered pair. That should be really obvious, and you're probably right. You'll notice with the rounding of the slope, it was a little bit off. I actually got 88.50877, which rounded to 8.5. And like I said, every time I draw the line of best fit, it's a little bit different. So when I initially wrote this problem, 8.5 wasn't one of my data points. So the 85 wasn't one of my data points. So it wasn't a data point I was calculating there. But it is kind of neat to A, see that we are getting the right answer, and B, because of our rounding, it's a little bit off, but it still works. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.